Hi, I'm Mr. Parker and this is question 2 on the OCR Mechanics 1 paper from January 2009. For more questions on this exam paper, click the link here to load the playlist or look in the video description below. Question 2. A trailer of mass 500 kg is attached to a car of mass 1,250 kg by a light, rigid, horizontal tow bar. The car and trailer are travelling along a horizontal straight road. The resistance to motion of the trailer is 400 newtons and the resistance to motion of the car is 900 newtons. Find both the tension in the tow bar and the driving force of the car in each of the following cases. So in part 1 we're going to consider when the car and the trailer are travelling at constant speed. So things we need to work out in this question, we're looking at the tension in the tow bar and also the driving force of the car. Now whenever you've got any system which has got two things that are connected together, like in this case a car and a trailer, there are three separate things you could consider. You could consider the whole system, which is the car and the trailer all in one go. You could consider the trailer on its own and what forces are acting on that, or I could consider the car on its own. Now at the moment I've got two unknowns. I've got a driving force that I don't know and a tension. In order to solve that problem, I'm going to consider the case of the whole system first, because in doing so I can ignore any internal forces, and that means I can ignore this tension, and you'll see why when I've drawn the diagram. So I've got a trailer which has got a mass of 500 kilograms. And the car has a mass of 1,250 kilograms. Next we'll add the forces to the diagram. So we've got a driving force pulling the car forwards, and we'll say that is D. We've got two resistive forces. We've got one applying on just the trailer, and that is 400 newtons. And we've got one which applies just to the car, and that's 900 newtons. We also have tension in the tow bar here. Now if you think about the tension acting on the trailer, that's pulling it forward, so we've got a force T in that direction. And if you think about the tension on the car, that's pulling it backwards. We've got a tension T there. These T's are the same value. So when we consider the whole system in one go, these two forces, the internal forces, cancel out and we can effectively ignore them for this problem. So let's write down our force equation, F equals ma. We've got D going to the right, we'll take that as positive. We've got 900 and 400 in the other direction, so we'll say subtract 900 and then subtract 400. And that will give us mass times acceleration. In this case, constant speed, this means that acceleration is 0, so we'll get 0 on this side of the equation. So what we've got to do to find the driving force is add 900 and 400 to both sides, and we get D equals 1,300 newtons. Now that I know the driving force, I've got one less unknown. The only thing I don't know is the tension here, which I'm going to work out next. So to work out the tension, I could consider either the trailer on its own or the car on its own. I could use either now that I know this. I'm going to use the trailer because that will involve less forces in the problem. So for the trailer on its own, I have this force diagram. I have a resistive force of 400 newtons. I have my tension pulling the trailer forwards, and I've got my mass of 500 kilograms. There are no other forces acting on the trailer. Because the trailer has to move at the same acceleration as the whole system, acceleration is still naught. So I can say to the right is positive, we've got T minus the 400 newtons resistive force, and it's going to equal 0 again because we've got no acceleration still. So T is going to be 400 newtons. So the driving force was 1,300 newtons, the tension was 400 newtons. In part 2, we're interested in the case where the car and trailer have acceleration of 0.6 meters per second. I've borrowed these diagrams from the previous question. Again, we're trying to find the tension and the driving force. Because the trailer and the car are connected, we can say that the acceleration for the whole system and for the trailer only is 0.6 meters per second squared. So we're going to do this problem much the same as we did before. The only difference will be on the right hand side for mass times acceleration, this time we won't have 0. we've got driving force going to the right, we've got minus 900 and minus 400 because they're going to the left. This time we work out the mass by combining the two separate masses and get 1,750, and we're going to multiply that by the acceleration, which is 0.6. To get d on its own, we need to add these two terms to the other side, so that's like adding 1,300, so we get 1,750 times 0.6, add 1,300. And we get 2,350. Next we'll work out the tension using the trailer again. So we've got the tension minus 400, that's the net force. And that's going to equal the mass in this case, which is 500, times the acceleration, which is still 0.6. We could use our calculator for this, but 0.6 is like 3/5, and 3/5 of 500 is 300. So I get T equals 300 plus 400, which gives me 700 newtons. Use your calculator if you need to, but that's fairly straightforward. So we've got a driving force of 2,350 newtons and a tension of 700 newtons.